All right, I'll jump in. Thanks for joining. We've got the, I guess we got the Cambridge crew here, right? All right, all right. Well, so I'm Larry Wikelius, and I'm with Marvell. I'm in charge of all of our partner engagement, software strategy, a number of other things that I'll touch on throughout this presentation. I'm going to go kind of quick because we're a little bit squeezed on time, but just for those of you that aren't familiar with Marvell, we are a silicon company. We build silicon for infrastructure, for switches, for servers, for storage, for wireless. It's a very strong portfolio across a number of key areas, but we focus on silicon, so we'll partner with system companies in terms of actual go-to-market. I'll talk about some of our partners and what we do. Marvell just completed the acquisition of Cavium. So on the right-hand side here are the products that came into Marvell as part of the Cavium acquisition. So we've really created a powerhouse on the infrastructure side. You can see the investment we do for innovation in terms of our patents and everything else, but you'll see that as I talk about the products here also. So the focus today is our ThunderX2 product. So ThunderX2 is our silicon for server processor. It is an ARM-based implementation, so we're taking ARM into the data center. You probably all have ARM in your pocket as you're sitting here with a phone or on your wrist, but now we are seeing ARM at the level of performance and capability that we can compete at the highest levels, the most demanding areas of compute. So in particular, what we've done is we have a very dense core implementation, so we have 32 cores per socket, and in addition, we focused a lot on memory. So we have 8 memory channels in our SoC. So I'll show you some of the streams benchmarks, for example, but a third higher memory bandwidth performance because of that investment in the memory subsystem, which translates to significant performance improvements on applications that historically have been memory bound. On the right-hand side here, you see some examples of some analysis that Dr. Simon McIntosh-Smith from the University of Bristol has done, comparing Broadwell, Skylake, and ThunderX2. And in most cases, ThunderX2 wins on direct performance comparisons, but where it really shines is performance per dollar. 2 to 4x from a head-to-head comparison for existing Intel-based implementation and deployment. We'll talk about this some more, but these are validated third-party examples of our performance advantages. So here in particular, on the left-hand side, you see spec-in rate, and on the right-hand side, you see stream. So this is where, at a socket-to-socket comparison, you see the benefit for integer because of the additional cores and optimization on the compute side. And on the right-hand side, you see the benefits for memory bandwidth because of our additional memory channels. And that's been a key differentiator in the server market and especially in a lot of HPC codes. Those codes that I shared with you previously on the GW4, most of those are Archer codes. Archer is one of the UK national services. We've been spending a lot of time on optimization. Big news this week for us is for the first time ever, there's an ARM system that's now part of Top 500 with the Sandia Astra system. So we came in at 203 for LINPACK results. This is in partnership with HPE, the Apollo 70 platform. But this really demonstrates the capability of performance, deployment, and just level of maturity that you're now seeing in an ARM-based platform with ThunderX2 in these kind of environments. So it was really gratifying to be now part of Top 500, especially with attention of that around SC18. A lot of other announcements this week, ranging from end-user announcements, CA and the French nuclear work, other Department of Energy in the United States with Los Alamos. I talked about Sandia. Los Alamos is also investing into Marvell for accelerating technology development and research. And one of the reasons I'm here today in the DDN booth is we announced Lustre support, commercial support, from DDN for Lustre client and then building the Lustre server. So that Sandia platform I mentioned, it's a Lustre environment. It's been a great partnership with DDN and WAN Cloud to drive both not just the porting but the optimization of Lustre on our platform. The other thing I'll add is we've got a couple of cases of HPC cloud offerings as well. Burn Global in Europe, HPC Systems in Japan. So as you have codes that you want to test or port or optimize, easy access to platforms and initial starting point before you actually bring them in-house. We'll quickly through our OEM partners, blue chip partners like Cray, Atos Bull in Europe, HPE with the Apollo 70, all standard kind of system infrastructure that you would expect to see in your existing data center, but now with ThunderX2 as an ARM implementation. With Cray, it's the Aries interconnect. With HPE, Mellanox, and InfiniBand. So very rich, full I/O and PCIe environment also. The other thing we do is work with ODMs. So ODMs will do the initial board design that OEMs may consume. In other cases, like large cloud end users, they may work directly with an ODM for design. In other cases, we'll work with Gigabyte for reference systems to seed the market. So again, a broad ecosystem on the hardware side. I touched on some of these already in terms of the customers from Sandia to Los Alamos, CEA in Europe, as I mentioned. Isambard is another UK implementation. A couple of interesting things here. On the upper right is our work with Microsoft. So Microsoft is moving the Azure infrastructure to ThunderX2 and an ARM infrastructure as well. So this isn't necessarily Microsoft shipping Windows Server out on ThunderX2, but it's expanding that infrastructure in areas like search, database, storage, major infrastructure that now can leverage that differentiating capability we have both for compute and memory. The upper left is our Catalyst UK program. So this is deploying the Apollo 70 platforms into 3 leading institutions in the UK, Edinburgh, Leicester, and University of Bristol, for additional application and software porting and optimization. So the thing we're active in is standards and standard setting in the ARM ecosystem. So ARM now has a program called Server Ready. It's a means to validate consistency with the ARM architecture. So if you're not familiar with ARM's model, ARM does not sell SoCs or silicon. They license IP. Right? So Apple uses IP when they build a phone. Right? Well, we license that IP for our servers, ThunderX2, but then we optimize with our microarchitecture changes. But we still adhere to the ARM instruction set architecture. So these are ways to validate both at a firmware level and a platform level that we're consistent with that implementation, such that as you're a customer consuming that, you know you've got a standard implementation of the ARM architecture. One of the things that we've been particularly active in at Marvell is driving the overall software ecosystem, as ARM has been a new presence in the data center. So just kind of build up what we've done in the stack. At a firmware level, full UEFI and ACPI support. Our own engineers do that. We partner with AMI, who's a leading firmware and system management BMC vendor in the market as well. So you have commercial support or your open access to a UEFI stack. On the system software standpoint, it's a little bit of a logo game here, but it gives you the sense of all of the distros that are enabled. All major Linux commercial vendors commercially support ThunderX2. Oracle, Red Hat, SUSE, Canonical. Also up the stack as we think about containers with Docker and Singularity. VMware actually demonstrated ESXi at a conference earlier this year. And obviously Lustre, as I talked about also. We drive a lot of the open source enablement through standard Linux kernel, standard tool chain as well. And on the tool chain front, rich offering of development software, open source, GCC, LLVM, OpenJDK, but also commercial. So ARM has commercial Alinea tools and compilers, as well as you look at other tools vendors like RogueWave, HPE with some of their cluster management software, Mellanox with their InfiniBand stack. So broad offering of, again, open source, commercial, you get it covered very well. And finally, I want to take a look at the application side. So as we moved up the stack this year in particular, we focused a lot on our application enablement and optimization in a couple of specific segments. So data analytics with Hadoop, for example, we've got public engagement with the University of Michigan, where a number of their researchers are using Hadoop for research and analysis on ThunderX deployment. In the physics, chemistry area with things like Quantum Espresso and LAMPS, these are open source stacks. all of which today we have public recipes hosted on the ARM GitHub website. So if there's a recipe like this, I think we're somewhere in the 50 to 60 number of applications that are out there. So as you want to see if your application that you care about, the recipe in terms of best recommended compiler, libraries, compiler flags, it's a quick, easy jumpstart to check out what an application profile looks like on this platform versus maybe one that you historically have used or run with. Similarly, a lot of weather codes, and these are some of the most complex and, as the developers themselves would say, gnarly codes out there. And these have been easily ported over to ARM platform and optimization. And then the final two segments with EDA and CAE, more of a commercial focus. So Cadence, for example, one of the leading EDA vendors, has ported and now supports the Excellium stack and has validated that on the Apollo 70. Other EDA vendors also have ports available. And then I have Flexera up here because Flexera is the leading licensing software vendor. So for a Cadence to monetize their solution, they need Flexera licensing tools, which is fully enabled on our platform as well. And then just this week, we've had presentations from both Ansys with Fluent and Altair with Radios as commercial ISV apps in this space that are showing anywhere up to 20% performance advantages running on ThunderX2. Others like then OpenFOAM, more of an open source stack. And then finally, the partnership with DDN. So I mentioned we had this announcement this week on professional support for Lustre clients. We've been jointly engaged on customer deployments, places like Sandia, as I mentioned. Today the focus is client, but we're also now working a lot more on server as we look at other scale-out type application deployments and infrastructure at a similar scale to the Sandia Astra platform.